Hi guys, Ms. Berg again. I am going to be going over 6.6 today. So it is on adding and subtracting mixed numbers. So the only difference is you still have to do a common denominator for your fraction part. The only difference is you're just going to have whole numbers to add as well. So add or subtract. So I am going to flip this around to explain it. All right, so this one says Denise mixes 1 4/5 ounces of blue paint with 2 1/10 ounces of yellow paint. How many ounces of paint did Denise mix? So what they want to know is how much they mix. So you have to add these two to see how much was mixed. So in order to do that, you would come over here and you would add these. Now, same rules apply. You must find a common denominator. First. So you have to do this first. So in this case, there is a way to do this. First of all, again, you're just doing the common denominator of just the fraction part. So in this case, the denominators are 5 and 10. So if you wanted to do the quick way, you could do 5 times 10, which is 50, and change all of these to 50ths. The other thing you can do is figure out the bigger of the two, which is 10 in this case. So then you go by multiples of 10. So 10 times 1 is 10. Can I get a 5 up to a 10? And this is true. I can change them all to tenths. So that is what I'm going to be doing here. Well, since this one is already in tenths, I am just simply going to slide over everything. The whole number has to be slid over as well as the fraction. But over here, my whole number is fine. I'm not changing up the whole numbers at all. The only thing that I'm going to be changing is the fraction part. So how do I change a 5 to a 10? I times it by 2, and then I times this by 2. So 4 times 2 is 8. So now, can I add just the fraction part? And you should be saying yes, because they have common denominators. So what is 8 plus 1 is 9 out of 10 slices. And then here, if you look at the whole number, you have 2 plus 1, which is 3. And this is your answer. So it was 3 9/10. Now it says, what other common denominator could you have used for this? So you saw how we changed to 10. The one that we could have used also is something that we talked about up here. If we use the quick way, it would have been 50. We could have changed everything to 50ths as well. All right, so next one. Here it says you are going to subtract. You can use the common denominator to find the difference of the mixed numbers with unlike denominators as well. So same thing goes. You need to find a common denominator first. So here, the denominators that are here are 6 and 4. Some of you may choose to do the quick way of just finding a common denominator and seeing that 24 can, you can change these all to 24ths, which is fine. You could do that. Or you can go my way, which is finding the bigger one, which is 6, and go by 6s until the 4 can go into it as well. So 6 times 1 is 6. Can a 4 go into 6? No, it cannot. So then 6 times 2 is 12. So can a 4 go to 12? Yes, it can. So therefore, we just found a common denominator here. We can change these all to 12s. So that is what I'm going to be doing. Again, only the fraction part is going to change, but the whole number still needs to remain there. It's still very much part of it. All right, so what do I do to a 6 to get it to 12? I times it by 2 and I times this by 2. So that would be 10 twelfths. Here, what do I do to a 4 to get it to 12? I times it by 3 and I times this one by 3. 3 times 3 is 9. So in this case, 10 minus 9 is 1/12. And then here, 4 minus 2 is 2. So therefore, your answer is 2 and 1/12. Next, here, it says find a common denominator again to change these to equivalent fractions, just like we have been. So we have a 5 and a 4 as our denominators. So which one is the bigger of the two? It is that 5. So I'm going to go by 5s until I can get a 4 into it. So can a 4 go into 5? No, it cannot. So I'm going to go 5 times 2, which is 10. Can I get a 4 into 10 evenly? Again, no, I cannot. So then times by 3. Can I get a 4 into 15 evenly? No. And then next is, can I get a 4 to a 20? And this is true. So I can go ahead and change them all to 20ths. So my whole number is still going to remain 7 whole pizzas. My denominator is just going to change to 20ths. So if I have a 5, what do I do to get it to 20? I got to times it by 4. So then I got to do the same to the top. 4 times 2 is 8. Over here, again, my whole number stays the same. The only thing that changes is my denominator is going to be a 20 as well. So 4 times what will give me 20? It is 4 times 5. So then I times this by 5. So that would be 15. So then here, what you do is now you can go ahead and add because they are all 20ths. So what is 15 plus 8? 15 plus 8 comes out to be 23 20ths. And then this one is 11. Now here is an issue. Why is this an issue? Because we have 11 holes, but then we also have 23 20ths. Now remember from that one video that I had showed, this is like a big head or an improper fraction. We cannot have that. So in order to change this, we are going to divide this out to see what it really, really means. So 23 out of 20. How many 20s go into 23? That is only once. So that would be 20. When you subtract, that would be 3. So the mixed number here is 1 whole and then 3 20ths. 3 over 20. So here, what this truly is showing is 1 whole and 3 20ths plus 11. 11 wholes. So what is 3 20ths plus nothing? Well, that comes out to be 3 20ths. That does not change. But the only thing here is what is 11 plus 1? It is 12. So therefore, my answer would be 12 and 3 20ths for this. All right, next. Again, you're not going to be writing in simplest form. We've already discussed that. Don't worry about it right now. So here we go. And this one is 2 3/4 plus 3 3/10. All right, so we have a 10 and a 4. If you want to use the quick way, you can change them all to 40ths. Or if you choose to go and do it my way, which is finding the bigger of the two, which is 10, and keep going by 10s until you can get a 4 into it. So can 4 go into 10 evenly? No, it cannot. So then the next, going by tens, 10, 20 would be next. Can I get a 4 up to a 20? And this is where, yes, I can. I can get a 4 to a 20. So therefore, I'm going to change these all to 20ths. Again, the only thing that you are going to change is the fractional part. The whole number remains the same. So this still remains a 2. This one remains a 3. What do I do to a 4 to get it to 20? I times it by 5, and I times this by 5. 5 times 3 is 15. What do I do to a 10 to get it to 20? I times it by 2. So then I times this one by 2. 3 times 2 is 6. So now I can add these. So it is 15 plus 6. Well, 15 plus 6 is 21 over 20. And then my whole number is 5 plus 2, which is 5. I'm sorry, 3 plus 2, which is 5. All right, but the issue again is that we have a whole number and then an improper, which we got to separate the two. We got to figure out what that is. So we can't have an improper fraction. So now I'm going to go ahead and divide it out to figure out what that is. So 20 can go into 21 one time. When you subtract, that would be 1 remaining. So therefore, this is going to be 1 and 1/20th. So this is 1 and 1/20th plus 5 wholes. So 1/20th plus nothing is going to be 1/20th still as a fraction. And then my whole numbers is 1 plus 5. What is 1 plus 5? That is 6. So therefore my answer is 6 and 1/20th. All right, next one. This one, same thing. 5 3/4 plus 1 1/3. Again, we got to see if we can add the fractions first. We cannot because they are not common. So we have to find a common denominator. So how you do that is you could always do the quick way of doing 4 times 3, which is 12. So we can change these all to 12ths, or you could use it my way as well, going by 4s until a 3 can go into it as well. So 4 times 1 is 4. Can I get a 3 into it? No, I cannot. So then 4 times 2 is 8. Can I get a 3 into that evenly? No, I cannot either. So then 4 times 3 is 12. Can I get a 3 to go into that? And yes, I can. So guess what? Either way I chose, I would have gotten 12. So I'm going to change these all to 12ths. So what do I do to a 4 to get it to 12? Well, 4 times 3 equals 12. So 4 times what will give me 12? 4 times 3. So we're missing that 3. So I'm going to times 3 up here. And that would be 9/12. But we still got to slide over that whole number. That whole number does not go anywhere. Same thing here. My whole number still needs to remain a 1. What do I do to a 3 to get it to 12? 3 times what will give me 12? It is 4, so I'm going to times it by 4. So that would be 4/12. Now I can add 9 plus 4 is 13 out of 12, and then my whole number is 5 plus 1, which is 6. Again, we have a whole number and then with an improper. So what we have to do again is we have to split them to figure out what that is. So 13/12. 12 can go into 13 one time. That would be 12, subtract, that would be 1. So that would be 1 and 1/12. So 1 and 1/12 plus 6 wholes. So the thing is 1/12 plus nothing is 1/12. And then 6 plus 1 is 7. So my answer is 7 and 1/12. Okay, next one. Here again is the same exact thing. So I'm going to have 3 4/5 plus 2 3/10. Again, same thing goes. First I have to see what a common denominator is. I could go the quick way and do 5 times 10, which is 50. I could change these all to 50ths. Or I could use my way, which is looking for the bigger one, which is 10. Can I get a 5 up to a 10? I sure can. So therefore, I'm going to change these all to 10s. It's just less work for me. So here I'm going to change this to tenths. So again, my whole number still is going to remain a 3. So I'm going to slide that over. My whole number is still going to be a 10. Sorry, a 2. But this is in tenths already. So therefore, I don't have to change anything. So I'm just going to slide it all over since it's already in tenths. What would I have to do to a 5 to get it to 10 though? I would have to times it by 2, and I must do that to the top. 2 times 4 is 8. Now I can go ahead and add this. 8 plus 3 is 11 tenths. 3 plus 2 is 5. Again, we have an improper fraction with a whole number, which cannot happen. So again, we're just going to separate the two by adding it. And we got to figure out what 11 tenths is. So how many tens go into 11? That would be 1. 1 times 10 is 10. Subtract, that would be 1. So my answer would be 1 and 1/10. So 1 and 1/10. So 1 and 1/10 plus 5 wholes. So 1/10 plus nothing is 1/10. And then my whole is just 5 plus 1, which is 6. So my answer is 6 1/10. All right, here we go. Next thing. Here, again, you're going to do the same exact stuff. First, find a common denominator. So you could do the quick way of multiplying both of the denominators. So 6 times 3, you could change these all to 18ths. Or you can pick the bigger of the two, which is a 6, and keep going by 6s until a 3 can go into it evenly. So 6 times 1 is 6. Can I get a 3 to a 6? I most certainly can. So to save time, I'm going to choose 6 because I don't have to change the first one because it's already in 6. So I'm just going to slide that on over. But here I got to change these to 6. My whole number still remains. What do I do to a 3 to get it to 6? I times it by 2 and times this by 2. That would be 2/6. All right, now can I subtract these fractions? Yes, I can. 5 minus 2 is 3/6. And then this is 9 minus 2 is 7. So this is most certainly good enough for an answer. Some people may choose to reduce if they would like, if they see it. In order to reduce, again, I will show you. When you are reducing, you find the factor rainbow of 3, that top number. So 1 and 3. Now, you can see if 3 can go into both 3 and 6 evenly, and it can. So to reduce it, you could have divided both the top and the bottom by 3 of the fraction. So When you do that, how many 3's go into 3? It is 1. How many 3's go into 6? It is 2. So therefore, you could have also said it is the same thing as saying 2.5. So one of these two answers is perfectly good enough for me. I would, just to save time, just use that one as your answer. All right, next. You would do 10 and 5/9 minus 9 and 1/6. Now, the quick way again to find a common denominator if you're having a hard time is just to do 9 times 6, both of those denominators down here. And that would be 54. You could change all of these to 54ths. You can do that if you would like. Or you can use my way of finding the bigger of the two, which is 9, and then going by 9s until a 6 can go into it evenly. So 9 times 1 is 9. Can I get a 6 into a 9? I cannot. So then I'm going to go 9 times 2, which is 18. Can I get a 6 into an 18? Yes, I can. So I'm going to change these all to 18ths. But just the fractions are going to be changed. What do I do to a 9 to get it to 18? I'm going to times it by 2, and then I'm going to times this by 2. That would be 10/18ths, and then my whole number will be 10 as well. What do I do to a 6 to get it to 18? I times it by 3, and I'm going to times this by 3. So that would be 3/18ths, and then my whole number again stays as well. Now, can I subtract just my fractions? Yes, I can, because the denominators are the same. 10 minus 3 is 7/18, and then 10 minus 9 is 1. So therefore, my answer is 1 7/18. All right, this next one, same exact thing. You got to see if you can subtract the fractions, the fraction part first, as they are, and you should be saying no, you cannot, because the denominators are not the same. So then you could have done 3 times 6 and got 18, so you could have changed these all to 18ths, or you could use my way of finding the bigger of the two denominators, which is 6, and go by 6's until a 3 can go into it. So 6 times 1 is 6. Can I get a 3 up to a 6? I most certainly can. So therefore, I'm going to change these all to 6. Why am I changing it to 6? Because it's less work for me. Why is it less work? Because this one is already in 6. So I'm just sliding it over. Here, I got to change a 3 to a 6. How do I do that? I times it by 2, and I have to do the same to my numerator. So that would be 4/6. And then my whole number still remains the same. Now remember, we are subtracting, so do pay attention to the signs. They do change. So now can I subtract these fractions? I can. So it'll be 4 minus 1 is 3/6. And then 7 minus 3 is 4. So this is the answer. Also, some people might have noticed that, yes, this fraction can be reduced. If you choose to do that, you may, you do not have to. So going here, you can look at the factor rainbow of that top one, which is 1 and 3. Can a 3 go into 3? Yes. Can it go into 6 evenly? Yes, it can. So therefore, you could divide both the top and the bottom of this fraction by 3. So that would be 4. How many 3's go into 3? That would be 1. And how many 3's go into 6 is 2. So therefore, 4.5, it is also the same thing as saying this. So either of these two would have been accepted. All right, I want you to go ahead and pause this video and try 8, 9, and 10. 11, 12, and 13 on your own, just like what we have been doing. So please pause that and try those on your own. All right, so you should have paused, and just to make this go a little faster, you could have changed these to tenths or 50ths. It really didn't matter. So if you did this, it would have came out to be 3 7/10. Now, if you chose to do 50ths, the only difference is you would have times these by 5. So then that one would have been 3 and 35 over 50 would have been the answer to that as well. So either of these two would have been accepted. Next, you could have used the quick way of just doing 8 times 6, and that would have been 48ths. So if you chose to do that, the 48 one, I'll show you that in a minute, but if you did change these to 24ths as well, you could have done that. This is what it would have looked like. If you did change it to 48ths, it would still be 15. 48 would be it, so that would be timesing it by 2 and by 2. So that would come out to be 26 over 48. That would be another way to say that. All right, next. Here you could have, the only thing you could have done is just multiply the 2 or do the multiples, and you're still going to get the same answer, which is 6. So these would have been changed to 6. So then if you did that correctly, it would have came out to be 4 and 5/6. All right, next one. You could have used the quick way and did 24. If you did do that, the thing is you would still get 6 wholes. You would just multiply both the top and the bottom by 2. So that would have been 14 24ths. So you could have had 6 and 14 24ths as your answer, or 6 and 7 12ths if you chose 12 like I did. Next, you could have just chose 8 as a denominator, and you would have gotten this 1 and 3/8. Or you could have also have chose 8 times 4, which is 8 times 4 is 32. So you could have changed these all to 32. So if you did that, just to make this a little faster, your answer would have been 1 and 12 over 32. That would have been the same exact thing. All right, next. This one, to make this go quick, you could have changed them all to 12ths, or you could have changed these all to 48ths by doing 4 times 12. So if you did this by 48ths, I'm going to just show you what you would have gotten. You would have times this by 4 and that by 4. You would have gotten 9 and 16 over 48 if you chose to do it that way. And if you reduced it on down, you could have even have gotten 9 and 1/3 as another answer as well. So this is what you should have done. Just made sure that all the fractions had a common denominator, and then you were able to subtract or add. All right, so that is all for that. Now I'm going to come over to 22. Dakota makes a salad dressing by combining 6 1/3 fluid ounces of oil and 2 3/8 fluid ounces of vinegar in a jar. Then she pours 2 1/4 fluid ounces of dressing onto her salad. How much dressing remains in the jar? So to make it, she is going to be combining this amount of oil with this much vinegar. And then when she combines it, then she mixes it. And then that's your salad dressing. Then she's going to pour out 2 1/4 fluid ounces. So they want to know how much would be left after that. So in order to do this, first you should have done 6 1/3 plus 2 3/8 to figure out how much salad dressing there was to begin with. And then after that, you could have just have subtracted off the 2 and 1/4. Now, to save some time here, the one thing that you could do is you could come up with a common denominator of all of these, so you guys are can just get that all out of the way right now. So I got a 1/3, and one that has a 3, an 8, and a 4 as a denominator. So what you would do here in this case, because there's 3 of them, you would start with the bigger one, which is 8. And then you go by 8 until they both can go into it, not just one. Both 4 and 3 have to go into it evenly. So can 4 go into 8 evenly? Yes, it can. But can 3 go into 8 evenly? No, it cannot. So now I'm going to go 8 times 2, which is 16. Can 3 go into 16 evenly? And this is where it's an automatic no, so I just keep on going. I'm going to times it by 3, which is 24. Can I get a 3 to a 24? I sure can. I already know I can get an 8 into it because we're going by 8s. And then can I get a 4 into 24? Yes, I can. So therefore, I'm going to change all of these to 24ths. So just to save some time, I'm going to change these to 24ths first. What do I do to a 3 to get it to 24? I would times it by 8 and this by 8. So that would be 8 24ths. My whole number will remain a 6. Here, what do I do to an 8 to get it to 24? Times it by 3 and this by 3. That would be 9 24ths. And then my whole number still remains the same. Again, we got to add this first. But before I do that, I'm just going to do this all. That would still remain 2 wholes. What do I do to a 4 to get it to 24? I times it by 6 and this by 6. 6 times 1 is 6. So here is the problem here. So when I do this, 8 plus 9 is 17 over 24. And so you go 6 plus 2 is 8. So my answer to this part is 8 and 17 24ths. Now I got to subtract off 2 and 6 over 24. All right, so 7 minus 6, 17 minus 6. If you do that, now I can do that because now they both have a common denominator. 17 minus 6 is 11 over 24. And then 8 minus 2 is 6. So my answer is 6 and 11 24ths fluid ounces are left. All right, it says this week, Maddie worked 2.5 hours on Monday, 2 2/3 hours on Tuesday, and 3 1/4 hours on Wednesday. How many more hours will Maddie need to work to make her goal of 10.5 hours a week? All right, now how you go about doing this is you got to first add up everything, and then hopefully that will come to 10.5. Well, we already know it's not going to because it's saying how many more hours will it take her to meet that goal. So I'm going to just show you how to set this up. On Monday, she did 2.5. On Tuesday, she did 2 2/3. And then on Wednesday, I did 3 1/4. So then it's saying how many more hours, so plus, I'll just say n, a variable, we don't know how many hours that is, n equals my 10.5 hours like I would like. So in order to do all this, I first should come up with a common denominator so I can add up all of these. So let's come up with a common denominator again, looking at your biggest one, which is a 4. Go by 4s until all of these, the 3 and the 2, can go into it as well. So 4 times 1 is 4. Can I get a 3 into that evenly? No, I cannot. So now I'm going to go on to my next multiple of 4, which is 8. Can I get a 3 into 8 evenly? Again, no, I cannot. So I'm going to go to my next multiple of 4, which is 12. Can I get a 3 into 12? Yes, I can. Can I get a 2 to a 12? Yes, I can. So therefore, I just found a common denominator. I can change these all to 12s. So I'm going to change this to 12. What do I do to a 2 to get it to 12? I times it by 6 and this by 6. So that would be 6/12, 2 and 6/12. Plus, here, what do I do to a 3 to get it to my common denominator of 12? I times it by 4 and this by 4. That would be 8/12. And then my whole number still remains a 2. Plus, what do I do to a 4 to get it to 12? I times that by 3 and this by 3. So 3 times 1 is 3. And that would be 3 and 3/12. So now I'm going to see how much that comes all together. So if you add up all of this, because all the denominators are the same, I can add up all of these numerators. So that would be 14 plus 3 is 17/12. And then my whole number is 3 plus 2 plus 2. So that would be 2 plus 2 is 4, plus 3 is 7. But again, this is a weird way of saying a mixed number. So we actually have to separate these two. So it's actually saying 7 wholes plus what? We're going to figure that out. So 17/12. How many 12s go into 17? That is 1. 1 times 12 is 12. Subtract that would be 5. So that would be 1 and 5/12. So my answer is 8 and 5/12. Okay, now this is how much they have done so far. Now remember, they want to get to 10.5. So what should we do to figure out the difference between these two to see what is missing? Well, now you need to subtract these. So 2.5 minus 8 and 5/12. All right, so to do this, we need to come up with a common denominator. First, look at your bigger one. Can I get a 2 to a 12? I most certainly can. So I'm going to just change my 2 to a 12 so that I don't have to change anything else because this one is already in 12s. All right, so what do I do to a 2 to get it to 12? I times it by 6 and this by 6. So that would be 6/12 and then 10 wholes. So now I could do 6 minus 5, which is 1/12. Then 10 minus 8 is 2. So that would be 2 and 1/12 hours are left. So that is our answer. 2 and 1/12 hours are left. All right. So now I am just going to go ahead and go right into your homework here. Again, you need to find the common denominator. And then, of course, you must show your work. That is a lot of work to be shown. So I should not just see an answer and that's it. Oh, so here we go. This first one, again, you do not need to write it in simplest form. It is up to you whether you want to reduce it down. Me, if I were you, I wouldn't, but that's totally up to you. All right, so I'm going to do this one with you. 2 1/3 plus 1 3/4. All right, so first thing that you could do is just use that quick way to do it, which is 3 times 4, and find out that you can change these all to 3 times 4 is 12. So I can change these all to 12s. So that is actually good, because if you use even my way, which is going by fours, 4, 3 does not go into 4 evenly, 8, 3 does not go into 8 evenly, then 12 would be next, and a 3 can go into 12. So either way, you're going to get 12. So I'm going to change these to 12ths. Again, your whole number still remains the same. The only thing that's changing is that fraction. So what do I do to a 3 to get it to a 12? I got to times it by 4. So if I times the denominator by 4, I must do the same to the numerator. 4 times 1 is 4. Over here, what do I do to a 4 to get it to 12? Times it by 3, and this by 3. 3 times 3 is 9. So therefore, when you add, it would be 13 twelfths, and then 2 plus 1 is 3. Now, can you have that as an answer? You should be saying no, because you should be seeing that big head. So when you have that, you should be separating this, because remember, a big head is always bigger than one whole. So we should just separate the two. And we know that this is going to be 3 wholes. Now we got to add what this is. So if you come over here, actually I'm going to do it over here. 13 can go into 12, 12 can go into 13 one time. That would be 1 left over. So my answer to that would be 1 and 1/12. So this would be 1 and 1/12. So when you do this, 1/12 plus nothing still means you have 1 slice out of 12. And then my wholes would be 3 plus 1, which is 4. So my answer is 4 and 1/12. All right, so you will have 3 and 4 for homework. You will also have 6, 7, and 9. So I'm going to do 5, 8, and 10 with you. You can cross out 11. That will not be happening. So here, if you want to use the quick way, 4 times 5 is 20. So I can change all of these to 20th. So we can just do that on this one. Again, watch your sign, because they do change up the signs on this. It's not all addition and it's not all subtraction. So be careful of that. So I already came up with a common denominator. I'm going to change these all to 20ths. So what do I do to a 4 to get it to 20? I times it by 5. And I have to do the same to my numerator to make it even, because I need to still be multiplying by 1 whole. So 5 times 1 is 5. And then my whole number is still 2. Here, what do I do to a 5 to get it to 20? I times it by 4 and this by 4. 4 times 2 is 8. And then I still have 1 whole. So now I can go ahead and add what is 8 plus 5 is 13 twentieths. 2 plus 1 is 3. So therefore my answer is 3 and 13 twentieths. All right, over here, I'm just going to be subtracting now. So I can use my quick way to come up with a common denominator. So I'm going to do that again over here. Just going to do 7 times 5, which is 35. So I'm going to change these all to 35ths. What do I do to a 7 to get it to 35? I times that by 5 and this by 5. So I'm still going to have my whole number of 5, but now 5 plus 3 is 15. Here, what do I do to a 5 to get it to 35? I times it by 7. So I do the same to my numerator. 7 times 1 is 7. And then my whole number is still a 2. So now I can go ahead and subtract. What is 15 minus 7? That is 8 over 35. And then 5 minus 2 is 3. My answer is 3 and 8 over 35, sorry. Next, Jill is walking 8 1/8 miles to the park and then 2 2/5 miles home. How many miles did she walk? So therefore, in order to figure out how much she walked altogether, you would have to add this. So we would have to take 8 1/8 plus 7 2/5. Just to make this a little faster, I'm just going to go the quick way of 8 times 5. 8 times 5 is 40th. So I'm going to change these to 40ths. What do I do to an 8 to get it to 40? I times it by 5, so I must do that to the numerator. 5 times 1 is 5. 8 is still my whole number. What do I do to a 5 to get it to 40? Times it by 8 and this by 8. 8 times 2 is 16, and then 7 wholes. So then 16 plus 5 is 21 over 40. And then my whole number is 15. So my answer is 15 21/40 miles. So 15 21 over 40 miles. And then you can box in your final answer. There you go. Next, on the back, the ones on the back are 1, 2, 3. We're going to cross out 4, but you will do 5 and 6. And that is all for 6-6. So this is your homework. And please submit a clear picture. Some of you are not giving me such good clear pictures. So make sure it is a clear picture of both the front and the back. All right. And we'll see you guys next time. Bye.